We have plenty of course to cover, and already we've been giving too much time to quizzes. Uh, Two lectures we gave previously to the quizzes, and then this week again we have two quizzes. So, yeah, clearly recording. Mute. All right. So let's continue our discussion on high definition link control. A lot of that will be you will study in some communication course. Uh, but since many microcontrollers have uh, LAN capabilities and USB capabilities which use these protocols, so it's good to know what's going on in the background in the hardware side. So this is a frame. Since, as I said, the clock is embedded in the data. When you are not sending anything, you are basically sending clock in synchronous protocol. So, and receiving, and we have this phase lock loop that can extract the clock from the data, so that the remote signal and the local clock generators are exactly in phase. And even if the local remote clock generator stops sending clock for a while, there is enough time before the local clock generator can drift out of phase. So there is a drift time for this local clock generator. So that makes it very so even before it drifts, the serial data in must get a clock to put it on the right path again. So high definition link control was created after data link control, and we talked about that last time. So beginning of frame, this is the frame component. So these are multiple bytes. First byte is single byte, beginning of frame. Then we have address, and this address may be needed if you are broadcasting like internet. And then we have some control information, some user information, some error checking system CRC, cyclic redundancy check, and then we have end of file. So these two bytes are basically bracketing the frame. This is opening bracket and this is closing bracket. As you will know, that when you study in detail, you will see that there are some opening brackets and closing brackets within some other components of the frame. So this is the opening bracket and closing bracket of the of single frame. So this beginning of frame byte is always this 8 bits. या इसकी जरा बात बंद करना है. 0 1 1 1 1 1 0. So that is basically 7E in binary and hex 7E. So this is called the flag. This flag never appears in the data anywhere. Basically, this 7 5 or 6 continuous ones never appear in user data. So you might ask how then we can transmit six ones contiguously in user data. So that we talk about that this is a non-return to zero encoding, and then we talk about bit stuffing. This is a very common term in communication, bit stuffing. So basically, bit stuffing means that when you send a frame must have 6 ones. If user has 6 ones, what happens is that it's always uh, after 5 ones, the user has always a 1 0 inserted on the transmission end, and the receiving end, whenever the data is received, after the receiver would discard 1 0 after 5 ones. That way user will never is never able to send 6 ones. And so if you so if you जरा यार ये धूम वगैरह करते रहना है zoom control. So if this is the data to be sent, 0 1 1 1 1 1 1 1 1 the user data is this. So the data that is actually sent is after bit stuffing is that after every 5 ones we insert a 0, and then 1 1 1 1 1 5 ones we insert another 0, and then we have other data to be sent 1 0 0 0. So this extra 0 is called bit stuffing. So user data is coming like this, user data, which may have long strings of ones and zeros or whatever. So you do bit stuffing. Now we never have more than 5 ones. No consecutive 5 6 ones. No consecutive 6 ones in this data. So this data is sent to the packetizing framing software. So this framing software inserts frames, framing, start of frame and end of frame packaging. This packaging, this kind of packaging is the user data. So this start of frame, beginning of frame, BOF, end of frame, end of frame. So on the receiving side, TX, on the receiving side, we have deframing software, deframing software. So if you are sending a Word document, it will be converted to frames, and after deframing software, you will get your Word document back, but it will have zeros. After every 5 ones, it will have zeros. So remove bit here. This will de-stuffing कह लें या unstuffing कह लें. I don't know if what's the proper name for this. आवाज आ रही? Right. So this will remove, uh, must remove a zero after 5 ones. This must add, without looking what is after 1 or 0, must add an extra 0 after 5 ones. And this must remove extra 0 after 5 ones. So you get the data back same again. So deframing software removes these beginning of frame and end of frame kind of and all the control information. And this over here removes these bit stuffed extra zeros that were stuffed in the data. And now here you can have a long string of ones. Here you cannot have long string of ones because every y ones you will have extra zero inserted. And now you will can insert this frame because these 6 ones can now only appear in your frame. They cannot appear anywhere else. So that way 6 ones, consecutive 6 ones are only unique to the communication, and that indicates that beginning frame or end of frame. These 6 ones only exist in this part, right before everything is done before this, but then the framing is done, these frames are inserted. थोड़ा नीचे कर लो यार, नजर ना आ रहा हो इधर. किधर है? मैं कर लेता. So anybody, इधर ही है ना सब लोग? किसी की आवाज नहीं आ रही? कोई क्वेश्चन भी नहीं आ रहा और कोई आवाज भी नहीं आ रही? People here?
Yes, sir. Assalamualaikum, sir.
Asram. हाँ भाई, समझ आ रही है? एनी क्वेश्चंस?
सर मुझे एक क्वेश्चन पूछना था. सर हम 5 1 को ही क्यों देख रहे हैं और हम 5 1 के बाद 0 ऐड क्यों कर रहे हैं?
क्योंकि 6 1 का क्या मतलब है? दिस इज द कंट्रोल इंफॉर्मेशन. ये वाली बाइट विद कंटेनिंग 6 1 इज फॉर फ्रेमिंग each frame. As I said, this user data may be hundreds of byte long. यूजर डाटा है, एक को सिर्फ फाइल भेजनी है या एक दूसरे भेजनी है. This could be hundreds of file long, and there is no stop bit and start bit when you are communicating on synchronous data. So this could be hundreds of bytes long. So it is converted into packets, variable length packets. So each hundreds of bytes of data is a couple of few 60 or 32 or 64 bytes का एक एक चंक उठाते हैं. This one chunk is then made into a frame by inserting this byte in the beginning and this byte at the end. So this would mean that one chunk of data, which could be multiple bytes, exists between this and this. So user data is converted into multiple bytes of packets. So this is under deframing software knows कि जब ये 0 1 आएंगे, मैंने इनके हटा के इसके बीच का डाटा एक्सट्रैक्ट करना. लेकिन उसको अगर यूजर में भी ये वाले 6 1 होंगे तो फिर वो तो मसला नहीं हो जाएगा. वो तो उसे ही डीफ्रेम समझ कर ले. फ्रेमिंग सॉफ्टवेयर उसको भी फ्रेम एंड और बिगिनिंग ऑफ फ्रेम और एंड ऑफ फ्रेम समझेगी. तो ये यूजर तो कैसे फिर प्रिवेंट करें कि वो ये वाला डाटा ना भेजे? यूजर ने तो हो सकता है काफी वंस भेजने हो, कुछ भी भेज सकता, आप उसको लिमिट तो नहीं कह सकते कि ये वाली बाइट कभी नहीं भेजनी। अब उसने डॉक्यूमेंट भेजना है, उसने बिट मैप भेजना है, उसने इमेज फाइल भेजनी है, तो उसमें तो हर तरह का डाटा एग्जिस्ट कर सकता है। So it is possible that there is all types of data there. So how do you prevent this byte to occur in the user data? You do is that after every 5 ones, whatever is the user data, after every 5 1 you insert a 0, and that you do before framing. So that way when the data reaches here after bit stuffing, it cannot have 6 1s. And then you can do this framing, that you can take chunk of data and bifurcate it with 0 0 1 at the end, or as this at the end. So this is how you frame this. Then you send this, and on the receiving side you deframe it, move this data, but you will have these bits, extra bits inserted over here. So these bits are then removed. So ये bit remove होगी, so you will get all these ones together again. ये bit remove होगी, so you will get all the ones together again. So you'll get the original user data back again. So on the receiving side, we remove these ones again. So that way, the user gets the same old data again. So this is why we do bit stuffing. Okay. Okay. So that's the job of bit stuffing. So I think I end my lecture here. This is a bit extra information. I don't think we need this. Basic information is the benefit of phase lock loop, and benefit of non-return to zero encoding, and the benefit of bit stuffing in framing. So these are the three uh, key terminologies that we have learned in this uh, synchronous communication. So so let's finish this here, and next time we'll talk about modems. This lecture about serial communication is over. The next lecture will be on modem, which basically takes this data and transmits over high frequency channels. So how that actually came into practice, that is the question. And so next time we'll talk about modems. Thank you very much.